just rebuild. I mean, it's 7 minutes for our one time everything fast. PSA with everything fast. But usually it has to rebuild. I mean, it's still getting rebuilt fast. Technically takes something like a month. Nobody rebuilds all the RPS. I would probably say it takes about 4 hours to build up. It's already in process. 3 hours. There's a lot of third parties. Boost takes forever. TMS takes 30 minutes to check out from SPF. Yeah, 30 minutes to check it out. It's like the process file resident is 3 of those.
Charlie and I go way back. No, not really. I don't actually. Test. Yep. All right, everybody, settle in. You're actually not giving me a talk. I'm just giving a talk about you. You can get on the podium. You're the only famous one here, Charlie.
This is the worst roast ever. It hasn't even started.
Your mic is on. Oh, thank you guys for coming out to Duo Tech Talks. I'm just going to ignore that guy. We might hear something from him later. So Duo Tech Talks is our monthly event that we hold here at Duo Security. We've got a full house down here, although there's 1 seat available, 2 seats if anyone else is still coming in. If you're upstairs, there's 2 seats available down here.
There's some in the back.
4 seats, 1 behind the pillar back there. And you guys can crowd into the machine room, possibly. So Duo Tech Talks is a monthly event we hold here, bringing some of our friends, quote unquote, to give talks at Duo about security topics, technology. We've stuck to a pretty strict security agenda so far, but we're open if Charlie decides he doesn't want to do security anymore. So before we start, we have to do a mandatory announcements. If anyone has any community events going on, feel free to shout out, throw your hands up. CTF Club. Oh, I think you volunteered.
So the Duo CTF team just got created probably last week. So if anybody, so that's not actually capturing the flags, physical flags. It's capturing flags inside computers. So it's competitive hacking almost. But if you're interested in that, you can come talk to me after this, I guess. We're open to accepting anybody from the community, so you don't have to be a member of Duo to join in.
Cool. Anybody else? The flags are inside the computer. That's what you're saying. Any? Where's Mr. Lanyard at? Any ARPSEC, MySec announcements? No, honey. All's good in Honeyland. Job announcements. I know we're hiring some people here at Duo. Back there.
Yeah, I'm Neil Borkwitz. I'm from FCA, used to be Chrysler, and we are looking for security professionals right now.
So FCA and Chrysler is looking for security professionals to stop Charlie from hacking their cars, pretty much.
They'd hire me, but I'm not professional.
It's a challenge. You can't hack Chryslers.
Oh, okay.
What's in your garage right now? Is it a Jeep? You have a Jeep, right?
Yeah, I got a Jeep.
Okay.
It's a great vehicle. I love it.
Charlie loves Jeeps, for the record.
The only problem is it has to go to the shop a lot. There's a lot of problems.
Yeah.
I was just driving and it went out.
I don't know.
Stuff's covered under warranty, as far as I know.
I don't know if you guys made it to Valisec's Duo Tech Talk a few months ago, many months ago. He was supposed to be our first one, but he missed the first one because he's a bad person. But he came to our second one and talked about when they hacked cars and they ended up bricking, I don't know, the ECUs or whatever. Computers in the car, and they drove it into the shop, and the dashboard is completely torn apart, and the Toyota mechanic is like, What is going on with your car? And Chris is like, I don't know. It's just stopped running. Anybody else? Ashley Vardiak, any announcements?
All right, our shameless plug, right? So Duo is hiring for security researchers, security engineers. We have a lot of front-end, back-end engineering positions. We're going to be looking for a growth hacker come this spring. What else? Sales engineers. So anybody on the solutions engineering side that wants to be involved with the customer and clients. Post-sales, we're looking for folks in London as well. So if you know of anybody in London, we're looking for a couple of positions, and we'll be posting for those shortly. So pre- and post-sales there.
Anybody else? Job hunting, job posting. Techstars event here Monday. Doug, where are you at? Not here.
He's upstairs.
Techstars Detroit will be holding an event here Monday. If you guys are interested in kind of the startup ecosystem in southeastern Michigan, come on out. We'll be back down in the basement, I believe. So more information on that, we'll send it out to the Duo Tech Talk list. So to get started here, I normally give embarrassing intros for speakers, but Charlie is very special, so I wanted to give something that was a little more heartfelt. Charlie and I go way back. This was actually a picture that my mom sent me earlier this week. I don't know if you can guess which one is Charlie and which one's me. Any guesses?
Neither.
Neither. It was a Google image search for boys holding hands. But Charlie started off growing up in the wonderful city of St. Louis, where he still resides. As we all know, St. Louis beat out Detroit for the #1 most deadly city in America, a title we were sad to lose. Also, Charlie made some bad decisions early on in his life. He decided to go to Notre Dame. Now, I just want to point out a few metrics here. The series record between Notre Dame and Michigan, NCAA football, no shame. But, Charlie decided to go into mathematics. Back when Charlie grew up, computers weren't really invented yet. It was very, very, very early on. I think you went to school with Alan Turing, if I'm correct, or maybe Babbage, I'm not sure. But South Bend, absolutely wonderful city. After graduating, Charlie decided to, straighten up and join the NSA, where he rubbed elbows with Edward Snowden on a daily basis. After the NSA, Charlie decided to go not straight and do a bunch of stunt hacking. So Charlie is responsible, if you see from the pictures here, for a lot of Apple ownage, whether it's on the iOS platform or OS X. Several of these shots here, not a very good quality picture, but Charlie doing the Heisman after the Pwn to Own competition, which I believe you won 3. Is it? Is that the three-peat?
Yeah, but then there was another year. I won 4, thank you very much.
4. So Pwn to Own is a competition at CanSec West where if you're able to own a mobile device or a browser with a client-side vulnerability, you win, a couple dollars and the laptop.
You win the thing, and then when I was doing it, $10,000. Then once I retired, $100,000.
Yeah, it got a little more expensive. But some other highlights of Charlie's career: he wrote a book with good buddy Dino, and he also has lifetime bans from both the Apple and Android app stores.
I might be the only person with that.
Yeah, I can't top you. I have 2 lifetime bans from the Android app store, but nothing from the Apple. Actually,
After the
2
first
consecutive.
one, it doesn't count.
I have multiple life sentences. I don't understand how it works, but you've definitely got the diversity, and I've got the depth. Charlie's also been hacking on some cars recently, so you might have seen him some Forbes videos, also on The Daily Show with Carson Daly in Times Square, with him and Valsec looking really nervous on national TV, showing how they can, I don't know, was it a Jeep that you guys hacked
It was a
on TV?
Ford Escape.
As long as it wasn't a Chrysler, because those are unhackable. Yeah. So besides research, Charlie has been a professional costume model. Actually,
I don't
earlier
think I'm actually wearing that doctor's outfit, just so you know.
I had to
believe that's
Photoshop him because I couldn't. We spent so much time on this presentation on our costumes and our piñata that the slides were in absolute disarray. But someone came up to us earlier today and said, "Hey, Charlie, I remember I saw your talk where you were dressed up in the costume." And Charlie's response was, "You're going to have to be more specific." Because basically half of Charlie's presentations are some goofy costume, like when he dressed up as a North Korean cyber army officer and then photoshopped pictures of himself with Kim Jong-il every other slide. And then there was about 3 slides of content through the entire talk. Nowadays, Charlie is a staff engineer at Twitter, where he spends most of his day responding to bug bounty reports and thanking people for the report and that they'll get a free T-shirt very, very quickly.
How the heck did you get that slide? That's impressive.
I think Chris deserves
yeah,
credit for that one.
Okay. Just so you know, that was actually a macro. Those are not my own words. So. No, I got people to do that.
But in all seriousness, Charlie has an impressive career. As you know, in security, most people's careers end when they turn 30. That's when you officially retire. And we're excited to host Charlie here for basically his greatest hits album. Now that he is almost officially in retirement, he's going to give a talk about sort of a lifetime of bugs and an overview of some of the research he's done. So Charlie's a great buddy of mine, and I love the work he's done. So I really want to welcome Charlie very warmly to Duo Tech Talks.
Thanks. I'm like 3 slides. You're going to have to hook me up. Serious. Okay, I need a clicker or something. All right, so this is the first time I've ever given a talk on not my own computer. I've probably given like 200 talks in my life, so I'm a little nervous about that. So let's see how it goes. So Jono invited me up here to give a talk, and I told him I don't really have anything to talk about. And he's like, well, just talk about anything. I was like, well, I can talk about that time I hacked the iPhone. He's like, yeah, just talk about that. So this talk is just like a bunch of stuff about bug hunting in general and like different bugs I found and exploits I've written and stuff like that. So that's it. I probably don't need to do this since that was such a great intro. I do remember that time we were in the park. It's great times. All right, so I might as well start out with my favorite bug of all times, which undoubtedly is this bug in Duo Security's Web SDK. I mean, for real, the guys who wrote this bug must have been total idiots. God, so bad. Anyway, what am I really going to talk about? So basically 2 things. One is like how do I find bugs? How do people find bugs? And then like just some bugs I found that I think are kind of cool. So what is the art and science of bug finding? So basically it's hard, right? If it was easy, there'd be no bugs because we'd just find them all like when we made them. So by its very nature, it's hard. And I mean the thing that's hard about it from my perspective is you look at source code and the bugs are like 1 line out of like 10,000 lines. So it's like really hard to find bugs. And the reason that bugs are so important is in this pyramid, which I've patented and copyrighted in case anyone wants to use this. It's what I call the pyramid of exploitation. And so the base of the pyramid is finding these bugs, right? So if you have a bug, that is what starts off everything else. So you have a bug, and then you write an exploit based on that bug, and then you install some sort of like backdoor or rootkit or something, and then like you do bad stuff. Right? So like you can't do the bad stuff without the bug to start with. And then like other things that make it hard is there's lots of different people looking for bugs, right? So there's the good guys like me. And then there's academics who like once in a while stumble upon a bug. And then sorry about that, U of M people. And then you got bad guys and then of course government guys doing it. And then the other thing that's sort of tricky about it is if you gave me, $10 million and said, okay, do what you would normally do, but now you have all this money. Like, I don't know what I would really do that much differently besides, hire a bunch of people. But like personally on me, like if you gave me tons of computing resources, I don't know if that would really help me that much. So it's very labor intensive and there's not necessarily a good relationship between how much you spend and like the number of bugs you find. All right, so what do I do? Well, the first thing that's important from like a researcher's perspective is what are you going to look for a bug in? So if you work for a company, you don't really have a choice. Your boss tells you what to look for a bug in. But like if you're just looking for any old bug, you have to choose out of all the programs in the world what you're going to look for a bug in. And if even if you're like, say, for example, looking for a bug in I don't know, like a car, like there's a lot of choices, right? Are you going to look at Bluetooth, or are you going to look at wireless tire, sensors, or whatever? And so like you have to make choices about what you're going to focus your time on. And so this is probably the thing that's actually the hardest to do, and the thing that I've been pretty lucky with so far, because otherwise you waste your time. And you only have so much time. So after that, then you do some like actual work, and I'll talk about all this stuff in a minute. All right. So how do you choose which software you're going to look for the bug in? And so it's a factor of these things. So there's like how distributed is the software. So like, does everyone use this, or does like no one use it? So it turns out the software that no one uses, like there's tons of bugs, and you can find them very easy, but no one gives a shit. So on the other hand, like if you look at some software that like everyone uses, like probably that's pretty hard to find a bug in. So maybe you don't want to focus on that, at least like when you're starting out. And then the other thing is like, well, there's bugs and then there's exploits, right? And so, woo, I don't even know how to fix that. So guy in the back, make it go back to how it was. Thank you. Okay, so then it's like, so just because you can find a bug doesn't necessarily mean you can exploit it, right? So you have to think about like how hard it would be to write an exploit on the system. And this is like one of the reasons that if you followed along like the arc of my career, I moved from like web browsers to mobile devices to embedded devices because mostly because of this. So like writing an exploit against like Chrome, even if you could find a bug, is super hard because of all the sandboxing and all this other kind of like memory protections. And so then I went to phones where it was easy, and then they added all the memory protections and stuff. So I was like, well, screw this, it's too hard. So then I went to like embedded devices where they don't have that yet. And so eventually they'll have it, and then I'll have to like retire for sure. So like if you want to figure out, this is just the last things I talked about in more detail. So if you want to figure out what to go after, it's like, well, you can kind of just like, there's stats on this kind of stuff. So like if you want to own 70% of internet web servers, then own Apache. But again, that's going to be really hard. And if you want to talk about how hard exploitation is, well, of course, there's things like memory protections and stuff. But even not even thinking about that, if you think about like how hard it's going to be to exploit, so how much data can you send a thing? Are you limited to like, if you want to attack Twitter, you can send 140 characters? Well, it's going to be hard to, even if you found an exploit, to really exploit that if you're limited to that little tiny payload versus like an entire PDF, which can be like megabytes big, right? And then, like, how much interaction is it? Is it like I send a thing and I forget about it? Or is it like JavaScript, where I have a lot of control over what's going on? And so it's going to be a lot easier to exploit something just to get, set up the heap and so forth if you have control over like a scripting kind of language. And then, like, how hard is it going to be to actually exploit? So, like, if you find some bug in port 135 of Windows, well, that's like super cool if you're on the network. But on the internet, there's not going to be that many hosts that have that open. But if you find a bug in Apache, well, every Apache server is obviously going to let port 80 in, and so it's not going to be a problem. Okay, so the other thing you can do is, like, I was a consultant for 7 years or something, and one of the things that you have to be really good at, or at least you get practiced at, is like within about 10 minutes, I can tell you whether I'm going to find like 1,000 bugs or one bug, because like you just know when you look at the code, you're like, oh, this code is terrible, or this code is like pretty good. So like this is basically what this slide is like. How old is it? Was it written in like 2001, or was it written 3 years ago? Are there like tons of new features constantly added, or is it pretty static? Like who wrote it? Was it some startup manned by a bunch of college kids from U of M? Or not to pound on Duo anymore, or was it like some professional software development shop? I can do this all night long. So then, like, what's the history? Has there been a bug reported every week or not? And then like just look at the code. Does it look crappy? Are there string copies everywhere or not? Another thing is like we don't really know how to measure how many bugs are going to be in code, but like one general principle that some people think is like the bigger the code, the more bugs, just because like the number of bugs is like proportional to the amount of code. So if you just look at how much code is in it, you can get at least a general idea of how many bugs you might be able to find. So the bigger things are probably going to be easier to find, so you can look at that. This is like some crazy picture of code coverage of the Linux kernel, which is massive. So what do you do? And the thing that I think about like looking for bugs is it's not really about, like there's not really any new things that I'm ever surprised about like, oh, I found this new way to find bugs, right? It's like, well, that really never happens. The thing is this, you have to just sit down and do it. Commit the resources to do it. So you just have to like, so you see research about this, but it's mostly just sort of very, very incremental improvements. So there's like two general approaches. One is like look at the code, whether it's source code or binary or whatever, and that's what we call static analysis. And you can have tools help you do that or tools to try to do it automatically, although these tools usually aren't that good. So this is you just sit down, you look for bugs, use tools if you can, and this is like what, it takes a long time. It's people ask me like, oh, does your math degree ever help you in what you do? I'm like, well, not really, because like I'm not really solving differential equations very often in computer security. But what it does help me do is like to get a PhD, you have to like work on a really hard problem. It takes you many years, and like a lot of the time you think you're going to fail, right? And so that's what basically bug finding is too. Is like, okay, I've looked at this thing for 2 weeks, I haven't found a bug, but I'm not going to give up. I'm going to keep going because I know that sometimes it's hard and it takes a while. If it was easy, everyone would do it. I tell my kids that all the time, and then they quit stuff. Okay, so the bad thing about doing it this way is that you need people to do this work, and so you can't really scale up to like a massive program because you need people, and it's hard. The other thing is like you might find things that kind of look like bugs, but they're not. So then you tell your developers, and they're like, oh, that's not even a bug, and then they don't want to listen to you anymore. The other thing is you might find something that looks like a bug, but you have no idea how to get an input to it. And it turns out like figuring out the input to get to that line of code is sometimes just as hard as like having looked for the bug in the first place. And then this is the worst thing is, especially as a consultant, someone hires you, you spend a month looking at their software, and they're like, how's it going? You're like, it's going great. I'm still looking at the code. You have nothing to show for your work, right? And except if you find a bug. And so that's sort of frustrating for people who are paying you a bunch of money. And that's how it goes. So here's some examples. First, like a theoretical example, and then like a real practical example. So like how does this thing fail? So like here's a function, right? It's called bar, and it looks like it could be dangerous, right? It's a string copy that's bad into a fixed length buffer. But like, what if every function that calls this only sends in small inputs? And what if this is like only called through a function pointer, and that function pointer is never called? So it's like, yeah, this looks bad, and if I was a consultant, I would flag that and say this looks serious or whatever. But to actually know whether it's vulnerable, you'd have to understand more about the program than just this line, and so that's why it's kind of hard. So here's another example of where stack analysis just like fails. So if you notice, I'm like obsessed with finding an Apache bug. That's like my life's goal. So like, a lot of these talks are about Apache bugs. So in 2003, there was this Apache bug. So here's the source code from it. And the actual bug is at this line. Instead of saying PS free equals node, it should say PS free equals active. It's like, how the hell are you ever going to find that, right? It's like, it's not like a string copy, right? You can't grep for this. This is something, you have to read every line of code and understand every line of code in this function to know what's going on. And so, like, there's no way anyone's ever going to find that, at least by reading the code. So the other alternative is to have, like, a computer to look for bugs for you. And so that's called dynamic analysis or, like, fuzzing. So this is something I like because it's easy and I'm lazy. So what you do is you just send in a bunch of inputs into the program that have been corrupted in some manner. What else do I want to say about this? So if it ever crashes, then that's like, it's bad, right? It might not be a security bug, but it's still some sort of bug. And the good thing is it's really a real thing, right? It's not like some theoretical sort of like, I think there's a bug here, but I don't know how to make it go off. So when is this bad? Well, the bad thing is like you get a crash, you don't know whether it's like a security bug or not. Sometimes like you don't know, it's hard to tell whether it's working, right? It's like I'm sending inputs and it's not crashing. Does that mean the program's good or does that mean your fuzzer sucks? I don't know. So you don't really know exactly what to send. You might have like too many test cases, right? If you try to make just completely random things, It might take forever to send in test cases. So there's some problems. And here's like again, a theoretical example of how you can imagine this failing. So here's a simple little program. In theory, you could send in like an infinite number of inputs, and depending on how long they are, different things happen in the program, right? And in practice, not infinite, but like still, like way too many that you'd want to send. So you're not going to be able to send in inputs to exercise every single line of code. And so here's my favorite example. And if you're on Twitter, like I like this example before Halvar did, but Halvar likes to talk about this example too. It's a very classic example. So SendMail is a program that Hillary Clinton uses, and other people use as well. And so there's a function in it called crackadder, and this is the function you pass into it some like big thing that looks like Charlie Miller, bracket Charlie at OpenRCE or whatever, and it's an email address, right? And it parses it out into whatever it needs to do. And so it turned out there was this bug, and you had to send in an email address that looked exactly like this. So it had to have open, close, and then a bracket. And every time you had one of those, it changed some buffer in some way. I don't remember the details. And so you had to put a bunch of those to change the buffer in some way. And then you had to have a bunch of these things to actually write over, like, past the buffer or something. So it was like this very, very, and if you had anything else, it didn't work. And so the idea was, like, there's no way you would ever randomly throw in that input, right? No matter how many, and it turns out that also, to make it worse, this function is so huge and complicated that there's, 2 to the 120 different paths through this function, even if you don't count the loops, and there's a ton of loops. So, like, there's no way you're ever going to do that unless you're reading the source code. And so this is an example of a bug that you can only find statically. So the sort of, like, middle ground is this thing called code coverage. So it's like, what lines have you hit in code? What branches have you taken? And so this is a way to measure, like, your progress, which is something you can do dynamically, which you can't do statically. Like, statically, it's like, yeah, I've kind of looked at the code. I don't know. I could look at it more or less or whatever. But, like, if you measure code coverage, you can see, well, I've tested exactly these lines and not these other lines. So the idea is you run your fuzzing test suite, and then you see which lines you haven't hit, and then you try to improve your fuzzing test suite to make it better. So this works really well because, like, the parts that you're not getting to, that's the important parts. And to understand how to get your test suite to go there, you have to understand the program, and then you might just find bugs statically as well. All right, so that's a small case study. Let's see. So at one point in my life, someone said, see if you can find a bug in WebKit. So WebKit is, and the reason was, like, we were interested in Safari bugs. So WebKit is like the HTML, JavaScript parser inside of Safari and Chrome, I guess, maybe, or for a while. I don't know if it is anymore. So we were starting to look at WebKit. And it turns out it's huge. There's thousands of files. And so we were going to, like, well, let's at least focus a little bit on JavaScript, right? So let me see. I got to make a phone call real quick. All right, so the important thing about this is that if you look at the actual documentation from the WebKit webpage, it tells you, like, if you were a developer for WebKit, you need to pass these tests, right? So there's, like, this test suite that is there. Hey, where are you, upstairs? Hey, dude, I need a drink. All right, okay, bye. All right, sorry about that. So the point is, like, the developers use a certain test suite, and so I was like, okay.
So sorry, Charlie.
Okay, I mean, Jesus, how long do I got to talk? I'm, like, getting parched here.
Jeez.
Well, at least I know how to get a hold of you. If you wouldn't have answered the phone, I would have walked right out, so well done. All right, so I decided to use their suite in C. So what I did was I instrumented WebKit, which meant, like, I made little changes to it to where it would record how much code coverage was covered. And then I ran their test suite, and I wanted to see, like, what code is their test suite testing and what code are they not testing. So then I put it all in this big database, and then I ran the test suite, and then I wrote this, like, cool GUI program. I was, like, really into, like, GUIs at the time. And I blacked out the person who paid me to do it. So it was, like, some company buddy, but now it's a black box buddy. So anyway, you could go through for each like test case. You could see like which lines it hit, and then you could see which files, like how much each file you did, and like for each file what lines you hit. It was really cool. But the main point was you could look at directory levels and see how much, what directories were they sort of ignoring. And it turned out that if you looked, that the main engine had been covered 81% of the time, so 82 really. So like most of the code had been covered quite well. But there was one little directory called PCRE, which was, it was a small part of the code, only 70% of the code, but they only covered it by 52%, so much less. So I was like, okay, let's look at that code because they haven't tested that code as well. So I wrote a fuzzer for PCRE, which stands for Perl Compatible Regular Expressions. And the way I wrote this fuzzer was I looked in the source code and I found all the things that they sort of had case statements for. So it was things like question marks, braces, whatever. And then I just wrote a fuzzer that just like mashed tons of those together and tried it. Also, I should mention for this talk, John O said I could talk as long as I wanted, so I plan to do that. So if at some point you get bored, if you leave, I won't be too upset unless I feel like being upset, and then I'll be upset. So anyway, I sent in these inputs into the program, and it never crashed. The program never crashed, and so I was kind of devastated. I was like, I did all this like super like PhD level, like I could have 10 PhDs from Carnegie Mellon kind of research. But what came out of it was no crashes. So it was like total academia here. But what I did notice was while it didn't crash, I looked in the logs and there was these like interesting lines that said things like PCRE compilation failed, internal error, code overflow. I was like, well, I like the word overflow. So I need to like figure out what's going on. If this is like a legit thing that I should care about or not. So I was like, did I win or did I lose? So I recompiled the thing to run under Windows. I use this tool called Rational Purify. I don't know if this tool even exists anymore. But anyway, it's similar to like Valgrind, for example. Had I done it today, I would have used Valgrind. But back then, I don't know if Valgrind existed or if I was just too stupid or what. But anyway, so maybe it was because it had a GUI. So it did have a GUI. And if you look in here, it says like, writing 1 byte, that is 4 bytes past the end of a malloc buffer. Like, so I had 1, right? So there was a buffer overflow. I corrupted memory in some way, although I corrupted memory in a way that was not enough to make the program crash, but that's fine. I can go from there. So then it's like, okay, well, is it exploitable? And I'll get to that in a little bit. So this is the teaser, so you don't all leave. Okay, so you're not supposed to talk about bugs you find when you're a consultant, but I've been out of consulting long enough, I think I can do that. So someone hired us to look at their little like C language authentication server, and it was so bad that I actually could still remember what the bugs were, and for some reason I didn't ever delete the project like I guess I was supposed to. I mean that I got it back from the employer who gave it to me, and I re-looked at it. That's what I mean. So anyway, here's a bug, I suspect. So this is the part of the program that you give it the username to authenticate. And then it's going to see whether like you're like a valid user. So it loops through and finds all the users. Does anyone see the bug here? If you find it, I will hire you at Twitter. Any bugs? Anyone? John O, come on. You're supposed to be a professional computer hacker. Just move on to the crowd here. Where's your computer security research team? Is that you? Come, no? Okay, well, this is why you guys pay me. So the problem is that you take the string length of the thing the user gave you, which is like your name, like Charlie or whatever, and then you're comparing, the thing they gave you, Charlie, versus like a real username, and then the amount of data that you're comparing it against is however long the person they gave you was. So like, suppose I give them say my username is C, right? And then it's only going to compare 1 byte of that. So if there's any usernames that start with C, then it passes, right? And even worse, if I give it the username like nothing, then it automatically passes because the length is 0. So this was a bug. That's bad. Okay, but finding a username, that's only so much. Like, you're still not in the server, right? You have to pass the password, too. So here's the password. I bet you guys can find this bug. So there's, some stuff, and then it does this, like, SQL stuff, and can anyone guess what they did? All right, so there's SQL injection. If you give it the password, like a blah, 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 then it passes, right? So you can pass in a username of nothing and that password, and you're in as root, because root's the first user in the list, right? So that's bad. But, like, you're logged in as root. That's not the same as running arbitrary code, right? Which is way cooler. So here's another bug. And this is all in, like, one file, right? I was just like, I mentioned to you, like, as a consultant, you get the idea of, like, when you look at code, when it's horrible or when it's, like, okay. And this was, like, horrible code. So here is, like, if for some reason you failed to log in, which I can't imagine how you could possibly fail, it logs it, right? So does anyone see the bug here? What's that?
There's a cough, well-timed cough.
Oh, okay. Anyone? No? No overflow? No underflow? You keep going?
Format string?
Yes. So it turns out that there's a format string bug if you follow the logic here. If you pass in that your username is like %n, it'll like crash the system. Okay, but like I like to make fun of vendors, and I like to like say how it's so fun to find bugs, and like I'm so awesome. Especially if you read my Twitter stream, like you really think I'm awesome, and I think I'm pretty good. But I'm not perfect. So here is a bug. I worked for a consulting company, which I won't name, and I was hired by a company, which I won't name. But if you put two and two together, you'll probably figure out who that company was. And I was hired amongst some other guys, one of which claimed on Twitter he was watching this live stream. What's up? So we were supposed to look for all these bugs, and this bug slipped through the cracks. And so this bug was like, there was some, I don't remember exactly, it was like a system call or something, and you could just like, boop, right to like arbitrary kernel memory. And I saw it. Like, this isn't as bad. As I saw this, I was like, it looks kind of like you could just like write anything you wanted anywhere. And I was like, nah, they wouldn't do that, right? And so like I tried for like a little bit to try to see if it was true or not, and I couldn't figure it out. And I was like, I'm sure it's fine. And then like I quit that company, and then it was like my second week at Twitter, and like I see this article in the newspaper or whatever. I was like, I feel so bad. So anyway, the point is that like even I miss bugs. So like it's hard to find bugs, and you shouldn't feel bad. But everyone misses bugs, and even ones that like are like one-click insta-roots. Like, oops, sorry. Like, thanks for the like 500K. All right, so anyway, that was like a bug, some consulting fun. I highly encourage young people to become consultants because it exposes you to lots of different code bases and tools and stuff. But like once you've been that for a while, like it's horrible. Like your job is like every month you're hired by a new company who thinks like they're getting ripped off, and you have to prove to them that you're not. So it's awful. Anyway. I'm not a consultant anymore. So black box exploitation of the iPhone. So they had a trivia session tonight. There was one of the questions: who was the very first person to ever write an iPhone exploit?
Charlie Miller.
Yes. So I gave that same trivia question at like DEF CON Kids once. I was giving out books or phones or something. I don't know. No, they didn't say that. I'm okay with that. But anyway, they said, so I asked that question. I was like, does anyone know who the first one to write an iPhone exploit was? And no one raised a hand. I was like, I'll give you a hint. He's in this room right now. And it was like me and Moxie or something. And they were like, I was like, anyway, they eventually some kid figured it out and they won something. So anyway, the point is, in a world where there is no jailbreak, like, can you write an exploit for a phone that you have no way to get a terminal on, right? You have no debugging on it, nothing. Can you write an exploit? And this is how I did it. So now it's easy. Like any old joker like Jailhot or one of these comics, they can write exploits. Yeah, it's easy if you can jailbreak it, but like try doing it without jailbreaking. So anyway, everyone will hate me now. That's why I did that. I hate when people like me. So anyway, so this thing earlier about the regular expressions, it turned out that we found that a long time ago for Safari, but we couldn't figure out how to exploit it because, as John O pointed out, I'm a really old dude. And at the time, there was not the Alex Soderhoff heap feng shui had not been invented yet. And so it was like, dude, I don't know what to do. But when the iPhone came out, it turned out the same bug crashed the iPhone, and the iPhone didn't have the same memory protections, so we could actually exploit it. So the key regular expression was you had to have brace, brace, star, star, brace, brace. If you had that, then it would like do something bad. It would like overwrite a buffer by 1 byte or something. So what we did was like we had this iPhone. It was this like physical device you could hold in your hand, but you couldn't do anything with it. You couldn't like you couldn't SSH to it. You couldn't like GDB it or anything like that. It was just this thing. But the only thing you could do is you could plug it into your computer, and in like iTunes or like Xcode or something, you could like download crash reports. And so if you download a crash report, it says like it's sort of some information about the registers at the time of it crashing, which of course it's not going to crash very often, but if you fuzz it, it crashes all the time. So what we did was we just made like tons of different regular expressions containing this and just sent them at the phone and download the crash files and sorted through them until we would see something good. This is not the ideal way to write an exploit, by the way. But eventually we found one that was pretty good. So here's a crash report from the iPhone 1, which was made before most of you were born. These are the registers. And so the point here is if you know ARM assembly, which I'm assuming you all do, if this thing is like right to here and then right to here, right? And these things like, I don't know, maybe I control those things, right? They're sort of like regular looking. Maybe not, I don't know. It seems like there's a chance. And if you're like a super hardcore hacker like John O or myself, do you recognize what this looks like, John O? I'll give you a hint. I say it right here on this bullet point if you just want to read it.
Looks like it might be the unlinking of a linked list.
That's absolutely right. So
I never passed that programming interview question.
yeah. The problem when I go to interview at places is they don't ask this programming question. Otherwise, I would pass with flying colors. They asked me to write an implementation of a linked list. I was like, well, I'll tell you what happens if you corrupt a linked list. Anyway, so the point is this is the unlinking of a linked list, which happens in heaps when you're freeing a buffer. And back in the old days, this is the way that you got control of programs before anyone had invented heap feng shui. So this was good. It looked like it was the unlinking of a linked list, which meant I had probably corrupted heap metadata. The question was, how controlled were those two values? Were those could I really make those any value I wanted? And it turns out, and this is what computer security research is all about, if you're ever curious, is you find a bug and then you spend all your time doing something completely unrelated to what you're trying to do. And so it took a week to figure out how to write a regular expression that you could actually use these things called character classes. And it's all the time I'm doing this work that has nothing to do with my ultimate goal. And this is what it's all about. So a week later, I learned how to write character classes, and then I could control it in whatever I wanted. So I could put whatever I wanted in this buffer, or this register, I should say, and whatever I want in this register, and then I could write. I basically had to write. I could write anywhere in memory. Okay? And this is what the regular expression looks like at this point. So if you took your old iPhone 1, which I have one at my house, you could, and you went to this HTML page, you would be able to write anything, anywhere. But still, if I gave you an iPhone and I could say, you can write anything, anywhere, but you can't debug it, it's still kind of tough to make it do something useful. So what we wanted to do is then figure out what to do. And so what we started to do is well, I don't know where to write. I have no idea. We've never seen what the memory of this device looks like. No one ever has. So we're well, we do know where the stack is, right? Because it gives it to you. And so we can just start we'll just start overriding different values of the stack, and we'll just try all of them and see what happens. And so we started doing that. We tried different SP stack pointer values. We tried different values to overwrite. And eventually we got something like this. So what you'll see is here's the stack pointer, and here's the program counter. This is where it's actually executing. And they're really close to each other. So I'm executing code on the stack, which on the iPhone 1 you could do, which is not ideal situation, by the way. Okay, so then it was okay, so I have control of the program, even though I don't even know what the hell is going on inside the program. Now what do I do? It's okay, no one has ever seen the file system for the iPhone. So what am I going to do? So you can start to do things like just try to grab like random things. You get directory listings or whatever. So we eventually found a file that we wanted, and then we just wrote shellcode for a Mac OS X computer, so like a desktop, that did what we wanted in C. And then we compiled it with a cross compiler, and then we like just made it work. And so the first thing we did was we reverse engineered a bunch of stuff, and we figured out how to call it, and we did. So like here is like play system sound. So this turns out this is the little noise it makes when you get a text message, like So I guess that's actually the vibration. But anyway, you get the idea. I can imitate many sounds on an iPhone. So you just find the address and you call it, and that's it. So that was the very first exploitation of an iPhone. I will pause if you'd like to clap for that. Thank you very much. I'd like to point out I didn't do this for myself. Jake Honoroff was the guy I worked with, and then this other guy who probably doesn't want me to say his name. So there was 3 of us working. And then like 2 weeks later, they came out with a jailbreak, and I was like, oh, it's so easy now. So another thing I did that is like kind of a fun little exploit was, believe it or not, like many years ago, there was this thing called Second Life that people thought was like really cool. It was like World of Warcraft, except there was money involved, or you could say it was like, I don't know, like, what's some other online thing people use?
World of Warcraft for business.
Yeah. Right. Yep. As long as you don't mind flying penises in your meeting, it's like totally legit. Yeah, I know. So anyway, there was this thing called Second Life, and the reason I was interested in is it was a game, and I was kind of like, I wonder if you could like totally hack games, And the other thing I was interested in is like there was a legitimate way that you could take U.S. dollars and turn them into Linden dollars and back and forth, right? So it's like, well, if you hack someone in Second Life, you can steal their Linden dollars and make them into real dollars and get rich. So this sounds like it's something sort of appealing.
That assumes people in Second Life had actual funds.
Right. Well, at the time they did. Like, believe it or not, people actually had money. Like, real companies were in Second Life. It was unbelievable. And then they weren't. I don't know. It might still exist. I don't know. But this is like 2008 or something. This is a long time ago. So the idea is that it's this world. It's like, oh, here we go. It's like Minecraft with money. Oh, nailed it. That's exactly what it was. It was Minecraft with money. Minecraft, but you could buy stuff, and there were like corporations in it and stuff. It was crazy. So anyway, imagine Minecraft with money. So I was like, okay, I want to like hack it, right? And you're like, okay, well, everyone has this sort of thing on their desktops, and they're talking to the server and that sort of thing. So what can you do? Well, there's lots of different ways you could give data to the world. You could make objects, right? You can talk to each other and chat. You could actually make it spawn the browser, but that's super boring, even though like I can totally exploit a browser. Because then I'm exploiting a browser and I'm not exploiting the game, right? So I'll like be able to steal their cookies, but I won't be able to steal their Linden dollars, and I want their Linden dollars. Because those are super valuable. So anyway, the problem is that the only way that I'm talking to the other clients is by talking. I don't talk to the other clients directly. I talk to the server. And the server like sends my message to the other clients. So like it looks like this. So here's me, and then here's like, Duo engineers. And then here's the Second Life servers. They all play Second Life, I'm sure, or Minecraft at least. So if I'm like, hey guys, I say hi. So I don't send that directly to them, I send it to the servers. And the server's like, yo, attacker says hi. And they're like, oh my God, I can't believe attacker said hi. All right, so the problem with this is that like I don't have direct control over the data they get. They're getting sort of the sanitized version from the server. The other thing is like, if I do find a bug in the way that they read my message, like probably the Second Life servers have the same bug. And so instead of crashing my buddies, I'm going to crash Second Life, which is not what I want to do. And even if I do it, like Second Life is going to see all these messages going through them, and they'll log it for one thing. And at some point they can filter it and stop my attack, and I don't want them to be able to stop it. But there's one time when there's like an exception to their rule, and that's when it comes to multimedia, so like movies and stuff, right? So in that case, what happens is I'm like, hey, yo, Second Life server, there's this like object I made, and there's this video that goes with it. And so then So then when that happens, when victim, Duo engineer John, or how about Bob, says, like, it walks and sees this object, the Second Life server is like, hey, yeah, the media, you can go get it at this URL. And they're like, okay. The server's like, okay, I'll go get it. And the URL actually points to me. All right, so now this is one case when they're connecting directly to me instead of to the Second Life servers. And so the good thing about this is that, like, I control the media. I control when I deliver it. Oops. I control when I deliver it, and I control, like, if I deliver it, right? So, like, if I find a bug, the Second Life servers can't stop me. Also, like, I don't have to exploit everyone. I can just exploit, like, the people I care about. So this is, like, a perfect scenario. And so this is work I did with Dino Daizovi, who was mentioned in the earlier talk, or the introduction. It was so long, it was like a talk. So there's two ways you can get media into Second Life. One is through QuickTime Player API, and one is through Sound, which they use this thing called Fmod to do it. So we wrote. It turned out there was a QuickTime exploit available at the time, and so we built on top of that. It was the known bug and a known exploit that hadn't been patched yet. So we just built on top of that. And so while you would think QuickTime was like super safe and that they would compile it with all the right compiler flags, they didn't. And so even though it was a Stack Overflow, we were able to exploit it. And you can check out the details in my talk. So I don't think I have a slide on this. I could have actually prepared for the talk, I guess, but instead I'll just wing it. So we gave this talk, Dino and I, at ShmooCon, and we told the Second Life people we were going to do it. And back then, I wasn't very smart, and I thought, like, you should do live demos. Like people who do videotape demos, they're totally bogus, right? I don't do that anymore because that's stupid. But at the time, we were giving a live demo. So it was time to give the demo. We log on to Second Life, like literally live on the screen in front of everyone. And I go to the part in the world where there's the like exploit, and there's this dude there, and he's got this like sign, like a picket sign, like you would, like if you're protesting, and it says like hi ShmooCon or something, and it's one of the Second Life like workers who found out I was giving the talk and is there live, like protesting the exploit. I don't know, it was crazy. I wish I had a video of that, but I was like, I was like, okay, run the exploit. All right, so anyway, this is another example of like being a security researcher. Is like writing the exploit was like, it was technical, but like that's what we do. Like we did it. It took a couple days, done. But like trying to like get an actual media, like multimedia thing associated with an object in Second Life took forever. It was like a week and a half of me like trying to run their stupid GUI, right? So here's me. My like character's name was Sussy McBride. I don't know why. I think I meant Susie, but I misspelled it. So anyway, here's me creating an object, and so you have to figure out how to create an object and make it to where people will walk up to it. And as soon as the Second Life person sees the object, they'll be exploited. And it turns out after some, so I should say, there was a time when I was worried that I would exploit random Second Life people, and I felt bad about that. And so I built this like super secret lab. So in Second Life, I built this building, and then I would only have the object in the building so that no one could see it. And there were no windows in the building, right? No one was allowed on my property or whatever. So I was like, I'm being very responsible. This is very secure. And then like later on I found out, I was like, oh, it turns out you don't have to actually see the thing if it's just like in your area of, I don't know, being, you get exploited. So like eventually I found out you could just like put it underground. And if someone walked by, they'd get exploited. I was like, oh, well, I spent like 2 days building this super secret lab it didn't do anything, but it was kind of fun. Okay, so you have to figure out how this like Linden scripting language works and how to like make it to where there's this multimedia thing is attached to it, and this is what you basically have to do. So this took me like 2 weeks to figure out because there's like no documentation. So here's what it looks like here. You say like replace this with this URL, and then like this is the text to do it, and blah 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 blah. And then if you want to write the actual exploit, like the thing is you have to survive execution, right? So like you've corrupted the stack, but you have to keep the program going. You don't want it to crash. That's no fun. You want it to keep going. And you've overwritten this like structured exception handler. It's really hard. But anyway, you can check out the talk if you want more details on that.
I found the photo, by the way.
Of the dude protesting? Oh, I wish you could show it.
I tweeted it, but
Okay.
I don't know how to get
AV guy, can you get on this Twitter thing and like make it show up? Maybe by the end, okay. Well, you got like, I'll give you 5 minutes. It's just like I'm Captain Kirk and you're like, Sulu or whoever the engineer dude was. Anyway. No, it would not be Jordy, just so you know. Anyway, so the point is, like, we figured out how to continue execution even though it was hard, and we're like super elite hackers, and it kept going, blah, blah, blah. So we finished it. It worked. It was awesome. This is the object, right? So if you ever saw this object in Second Life, like, I owned you. So then it was like, okay, well, what are we going to make it do? Well, your credit card's associated with it, with your account. So we could actually make you take your credit card, buy like a ton of Linden dollars and steal them, but we didn't do that. But what we can do is we can figure out how much Linden dollars you have. We can steal all your Linden dollars, and then we can make you physically do so. That was the thing I was really interested in, is like, I was sick of making calculator pop up on a computer. I wanted to like do something like real, like, and I wanted to like control your person, like make them punch themselves in the face or whatever. Like all the things that the bullies made me do in 5th grade, I wanted to do to other people. And the only way I can do it with my 130 pounds is in a computer. All right, so here is the video of it. So this is me, the attacker. Here is the victim, Sussy. Here is the object. So when she gets close enough to where it goes off, she will pause momentarily as I take control of her. And then she will give me all her money, which happens to be 12 Linden dollars. And then she will shout. If in a second here, it will shout. Oh, there we go. I got hacked. So anyway, so I have complete control over Sussy McBride at this point. It's pretty awesome. And then all the like newspapers were like, this is really awesome. Like, he can steal 12 of your Linden dollars. Like, but only 12, so it's okay. Don't worry. I was like, I think you kind of missed the point. But okay, cool. Okay. So that's the story. We're done with Second Life. Off to the next one. Oh, thank you, Jono. Hey, while you're sitting there,
I got you.
Okay. I didn't want to call you when you're sitting there, but all right. So the next thing I want to talk about is this time I exploited SMS on iPhone, and one of the things I like about this story is that I told, I talked to people, like researchers, like, hey, what are you working on? And I'll be like, I'm going to try to exploit SMSs on iPhone. They're like, dude, you're stupid. That's never going to work. And the reason they thought this was, it's like, it's only 140 characters. It's just ASCII. Like, they can't screw that up, right? And I was like, I don't know. Like, I've worked with Apple a long time. Like, they screw stuff up. But anyway, the point is, like, no one thought that this was possible because it's such a simple thing, right? It's not like parsing a PDF where it's very complicated, or parsing, an HTML page with JavaScript in it and with images, and like, it's hard, right? SMS, like, if we can't do that right, like, we failed as an industry, right? So anyway, so I looked at this with a guy named Kyle Molnar, who Jado mentioned earlier as someone who apparently he thinks children might mistake me for and my work. But anyway, the idea was we wanted to fuzz SMS and see what happened. And we fuzzed iPhones, Windows phones, and Android phones. And we wanted to see what happened. And the reason that we were interested in SMS is, like, everyone has SMS. You can't stop SMS from showing up at your phone. You don't have to, the lame things about browser exploits is like, I got to make someone click on a link, right? So lame. But SMS, I just got to know your phone number. I'll send it to you. And the other thing that was, really great is eventually you'll see that I found a bug and then wrote an exploit. But when I gave the talk, people were like, hey, Charlie, yeah, I saw your talk, and yeah, I turned off my phone. Right? And I was like, oh, yeah, you're super clever. Do you know how text messages work? Like, I sent it, and you don't have to have your phone on. Like, it'll just sit in the carrier, and as soon as you turn your phone on, it'll deliver it for me. But cool, I'm glad you turned it off. But anyway, sorry if anyone said that to me who's in the audience. But the point is, it's like a great attack vector. There's no way to filter it off without turning your phone off to phone calls. It's the same functionality. So to get into some a little bit of technical details, SMSs come to your phone as a @ command. it looks like this. So like if you could see inside your phone, this is what a text message looks like when it shows up at your phone. It's like some like @ command and then like a bunch of data. And this is some data that I've broken out. And so the interesting thing is you'd think text messages are only text, but they're not. So there's a little bit of binary stuff, and that little bit is what got them. So you can break out this thing called a PDU, and it has things like links, addresses, some other stuff which I don't remember, but like data. And so that last thing I showed was like a simple one, but there's like other ones you can send that have like more data in it. And so this is like the most simple example. So I don't remember, this is user-defined header or something. I don't know. Colin, if he's watching the live stream, is probably making fun of me right now. But anyway, so the point is there's like a length, a type. Or no, this is like I don't know what this thing is. This is a type, a length, and then data of that length, right? And so for the different types, there's different things that can happen. The type that's sort of the most easy to understand is type 0, and which is concatenated messages. So like, have you ever sent a message to someone, like a text message that was more than 140 characters? A lot of times you can just keep on typing, right? I don't like Twitter where it stops you. Like you can just keep typing and it's like to blah, 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 at least on my phone. And you send it, and the way that works like underneath is it sends you one of these messages and it has a special data. And it says things like, the 0 means this is a concatenated message. And then this says there's 3 bytes of data. This says like, okay, this is like number 0, like, it's like an identifier. And this says expect this is going to take 3 messages, and this is the first one. So you get like data like that. That's what's going across the phones and stuff. So if you reverse engineer the iPhone, you'll see that it supports 0, which is concatenated messages, and then a few others. So we were like, okay, let's just fuzz the crap out of this. So we did. And we started to get crashes. And the first thing that crashed was Springboard, which is sort of the GUI for iPhone, because it was trying to display something. And it crashed, but it was like, if you've like fuzzed before, you'll recognize that this looks like a null pointer to reference. Not very interesting. We kept crashing, and then we eventually found this crash, which is in Comm Center, which is the process that handles text messages on an iPhone. At least it was. Who knows? Like you can see this is a long time ago. iPhone OS 2, right? A long time ago. But anyway, the thing that was interesting back then is they did have sandboxing and stuff. But this particular process, Comm Center, ran as root with no sandbox, which is another reason it was interesting. And after I gave this research, it no longer ran as root or as without being in a sandbox. So this is the kind of benefits that I've given all of you iPhone users. You're welcome. So if you start reverse engineering this thing, you'll see this thing which I call read next byte. It's like calling all over the place. But the thing that's interesting about this function is it returns the next byte. Shocking. But if there is no next byte, it returns -1 to indicate like, yo, there is no next byte. But if you look back at this code, it never like actually checks whether it returns -1 or whether it didn't. So what happens if you don't send in enough data, you can start making -1s show up all over the place. And so you can make it think that like the message you sent is -1, or like the total number of messages is -1, or whatever you want. And so it turns out that you can do some sort of like crazy stuff with this. And the thing that I did was there's this like array of like pointers to strings, and it like references an index into that based on which message number this is. And if you send in, and it checks to make sure like it's greater than 0. But then it like if you send a -1, it like totally beats the check, and it like does stuff.
Don't be nervous.
I'm a little like nervous about this. What is this?
Sunny D.
Sunny D?
Like we used to drink when we were kids.
It doesn't taste like when we were kids. I don't know what that is. It must be a Michigan thing.
Yeah. Is it ever clear?
So anyway, so I gave this Black Hat talk where like I spent like 30 minutes talking about how to set up the heap and all this stuff. But eventually the cool thing is you eventually can take complete control. And I'm sorry to any women in the audience that my favorite like hex string is Babe Cafe. But it rounded it up for me, so it Babe Cafe. Sorry. Don't blame me. Anyway, so that was cool. So the point was I could send you a text message and get root on your phone, which was kind of awesome. And so here's another story about this, since I just do whatever I want, since I'm the speaker. So I of course, being the responsible person of the internet I am, I reported this bug as soon as we found it to Apple. And I was like, dude, I don't think you can exploit it, but like here's a bug, like it'll return -1 when you're not expecting it, it'll crash. Like, okay, thanks, Charlie. And then like I went to this conference called Syscan, and Dave Vitale was there, and he's like, Charlie, you gotta make that exploit work. And I was like, fine. So I spent like 2 months making the exploit work. I finally got to work, and then like a week before Black Hat, I was going to present this work, or maybe it was like actually at Black Hat. Like one of the Apple guys came up, he's like, oh man, so you're talking about that SMS bug? I was like, yeah. He's like, yeah, it's too bad you never got that to work. I was like, oh, actually I did. They were like, they had never fixed it. And they were like, oh shit. And so they like the next day it was patched. So anyway, they were like really surprised, and I was like, oh nah, yeah, I got that to work. You should have tried. So anyway. So I would have to send you 519 text messages to set things up exactly, and then I would send you the one to totally wham you. It was great. And if it didn't work for some reason, you could just keep trying, because what are you going to do? Like, you're powerless. I can send you text messages. You can't stop me from sending you text messages. All right, so the next bug, I think this is the last bug of the talk, so we're in the final stretch here. So this is a bug in the code signing mechanisms of iOS. And code signing is really important in iOS because it's what stops you from being able to download apps except from the App Store, and it stops you from the apps you download from downloading new stuff or new code or updating themselves or anything like that. So any bug in their code signing like sort of changes the whole way that the iPhone works. So I found this bug, and so here's the code from the bug. So when you map memory, they're looking to see like if you have this special flag, which lets you do like crazy stuff you're not supposed to do. If you have that flag and this, then you don't let that happen. Or if you have this flag, don't let that happen. Or if you have this flag, don't let that happen. Okay, so don't let it. It turns out there's only one more flag that hasn't happened since then. And the only other flag that they haven't mentioned is this one, Mapanon. And so if you haven't done any of those, then you must have Mapanon. And if you have Mapanon, then they do this check. And they make sure that you're not doing anything funny. So if you could figure out a way to get by this and not go into this, then you would win. You would be able to do unsigned code stuff, which you're not supposed to do. So I looked at this code. Actually, so I looked at this code in binaries. This is like an interesting thing. Like people tell me all the time, like, well, like it's harder to find bugs in source code than binary. And I was like, well, I don't know. It's the same to me. So I found this bug in binary, and I wouldn't have found it in source code. So does anyone see the bug? Of course not. It's impossible. You can't find the bug. Oops. Okay, this is just what I told you. It only checks the entitlement, which is the thing that it checks to make sure you can do the bad stuff, if that Mapanon is set. So this is the key, is they have the pound define. And in the source code, I would have never found this bug. But in the binary, it was like totally obvious it wasn't checking something. And so does anyone now see the bug? Security researchers of Duo, you have a whole team devoted to this. Does your team read C code? All right, so the problem is if you set map file, let's see if it passes this check. Well, it doesn't do that. It doesn't do that. And now what about this one where it's checking it? Well, map file is 0. So 0 and 0 is 0, which is 0, and that's false. So it turns out that they screwed up, that they could have made this any other value but 0, and it would have worked great. But they didn't. They made it 0. And then, therefore, if you sent in something with map file, it would pass this check, and then it wouldn't go into here, and then you're golden. So if you wanted to allocate a region where you could write and execute code, which you should never be able to do on iPhone, all you had to do is send in that map anon, and I think that's what it was. Whatever. I've had too much so far. But anyway, you could bypass all their checks. And this would work on any app except mobile Safari, because there was some check where you could only do the bad thing once, and they already did the bad thing once, but no one else could, so they didn't. So here's the way you do it. If you allocate memory with mapjit, which is the thing that gives you magical powers, and mapfile, which lets you bypass all the checks, you win. You can write code and you can execute code. So this means that you could have an app that downloads new code anytime at once, which it should not be able to do. Apple does not get to check this code. You can have like exploits. Like exploits are hard on iPhone because you can't like ever download tools. You can't write shellcode that works. Nothing works. But now it does work all of a sudden. And so basically it turns out that any code signing is like super serious against iPhone. Being the responsible researcher I am, I reported this to Apple immediately. But I was kind of a jerk about it, I have to admit. I thought I was really clever at the time. But now that I work for a company that receives bug reports, I realize that what a big jerk I was. So instead of telling them what the bug was, I said, I don't think this does what you think it does. And I gave them the line of source. I thought it would be like sort of fun, like it's like a puzzle. They'd have to figure it out. But to their credit, they never wrote back and said like, "What are you talking about?" They figured out what I meant, so that was good. They figured out what I meant. So like I said, the bug was that you could have apps download new apps, essentially, right? But the apps have to go through the App Store process, and I was afraid. I'm from Missouri. That's the show me state, right? So I was afraid that they would say like, "Oh, sure." Like I've worked with Apple. I know what they would do. They would be like, "Yeah, sure, but we would catch any app that did this." Right? So I was like, "Okay, well, to show you before you tell me that you would catch this, I'm just going to do it." Right? So before I sent this email, I submitted an app to the App Store that did exactly this.
What app?
You'll see. Your name is even mentioned. I give credit where credit is due. I'm fair to share. Okay, so most of the App Store apps could download unsigned code. It would be like super easy and awesome, right? And so I wrote an app that did that. It downloaded unsigned code and ran it. It could do anything it wanted. But because I want to emphasize what a good internet citizen I am, that it only did that if it was, if I wanted it to, right? Which was never, except for me and Valsec. So we're the only ones who were ever exploited by this bug. So I don't know how to write apps. I'm a computer security researcher. I work for a company that makes an app, essentially, for their entire livelihood. But still, I don't know how to really write apps. So I contacted the one guy I know who knows how to write code, which is John O. And I said, John O, I need an app. Any app. I don't care what it is. I'm just going to put this secret sauce in it, and it's going to be able to do something really evil.
So, backstory, I don't know how to write apps either. The only apps I've written have been malicious apps.
Which is exactly what I'm trying to do.
I contacted my friend that I went to school with, Pavel, who had done
Pavel Malik, right here.
apps, and he provided the delivery mechanism, if you will.
Right. So I submitted 2 apps to the App Store, which both contain the secret thing that would download unsigned code and run it, which should not be possible. And if that code was not, it would call out to my server. If the code was there, it would download and run it. If it wasn't there, it would just do its regular thing. And that's what happened to like the normal person. And so this is the first app. The first app I tried to submit was called the Daily Hoff. Actually, initially it was just called the Hoff. And
it originally did get into the Play Store, or the App Store. When Pavel first wrote this app,
Yeah.
it was accepted, and it was a big hit, and he made a decent amount of money off of it.
So you don't really get what it does without look. But if you look at his crotch region, there's another picture of the Hoff. And what happened is if you zoomed, you would zoom into that, and it was like an infinite zoom into his crotch. So I submitted this app, but unfortunately it was rejected. But it was not rejected because it downloaded unsigned code and ran it. It was rejected because it said that, here's the thing. The features or content of your app were not useful or entertaining enough, or your app did not appear to a broad enough audience. I guess they thought it just appealed to Germany, apparently. Anyway, I know. So So that's why I eventually named it the Daily Hoff, because I was like, yes, it seems very simple. It's just you infinitely going into his crotch. But the thing you can't see is every day there's a new picture of the Hoff. And they still didn't go for it. So anyway, no one will know like how awesome this app is. It's still on like a couple of my phones. I think it's on my wife's phone. It's pretty sweet. So this app did not get in, but this app did, called InstaStock. So this is like a stock market tracking app. I submitted it. It got rejected, and I was like, oh, no, I'm totally busted. And it's like, we found that your app does not use one or more non-public APIs. That sounds kind of scary. It's like, we found the following non-public API. Add text field with value label. I was like, I can fix that. That's no problem. So then I did submit it again. It got in the App Store. It was in there for a couple of months. Anyone could download it, and it would, if I wanted to, make them run unsigned code. And so, like, after I submitted this, I told Apple about it. They knew about it. They had known about it for months. And then I was talking to a reporter, and I was like, yo, yeah, you should check out the app. Like, it's totally cool. Like, just download it. It's fun. And so I was out, like, jogging or something. And I came home, and my wife's like, Charlie, Apple just called. I was like, what? Apple doesn't call me. You know, like, I don't know anyone there, Harley. And so she's like, I don't know. Like, you need to call them back. So I was like, okay. So I called them back. And they had apparently seen the article. It had come out. I didn't know it. And the article, like, showed a video of the app, like, acting. And so I called, and it was some, developer services team or something. They're like, yes, we're going to have to remove your app from the App Store. I was like, okay. They're like, don't you want to know why? I was like, I think I know. And so they were the lady was kind of confused. And so then I was like, okay, talk to you later. So they removed the app from the App Store, and they banned me for a year from the App Store. And then, so after a year, I wrote them an email. I was like, yo, a year's up. Like, I'm ready to come back. And they never wrote me back. So I guess it was in all essence a lifetime ban. But anyway, so I stopped doing Apple, and I started doing car stuff after this. So here's what the app looked like when it was there. It was like a super awesome app. It worked great. Any customer ratings? No. It was rated 4+. Way to go, Charlie Miller, super app developer. So that's it. That's all the stories I have. I guess the conclusions are like, bugs are hard. I found some. Like, Apple will like crush you if you try to work with them. Follow me on Twitter. I need users. That's it. Thanks. You have some final words?
Any questions for Charlie? What happened with the Apple WebKit? You said you were going to tell us what happened.
Oh, I did. You just didn't pay attention. So the first iPhone exploit was the Apple WebKit thing. So that same bug that we found is the very first exploit for iPhone. Oh, look, here we go. Are we going to have the picture? Yeah. Here's the dude protesting right here. There is, here's Sussy McBride. And here's a sign, if you look closely. It says, it says, warning, exploitation in progress. So don't go near there. That was it. So yeah, it was kind of shocking when we went live and there was this little dude there. I don't know even how you make a little guy like that, but he was there. Other questions?
Did you play Second Life with something awful?
Did I play Second Life?
Did you actually play it, or did you just
I mean, not really. That's why I never, if I was a player of Second Life, it would have been super easy to do this stuff, but the problem was...
You mentioned something awful penis things.
Oh, that's just because if you do some research on Second Life, there was some super serious COO type, and she went for an interview with Time Magazine in Second Life, and some griefer sent thousands of penises through the interview, and she got super mad and sued people, like you do in Second Life. And she got mad and sued everyone. I don't know. That's all I know. But my experience in Second Life is this area right here, which I owned. No one could go in if I didn't want them to. I built the little cube. I built the super research lab, which I guess I destroyed because it didn't actually do anything. And that's my experience in Second Life. And I put some Linden dollars in so that I could steal Linden dollars, but that was about it.
Would you go back to work to the NSA at any point, or are you just going to stick with Twitter?
I'm not going back to NSA. So when I was at the NSA, we were told all the time that we didn't spy on U.S. people. And in fact, we went to training every year that talked about like how serious it was we didn't spy on U.S. people. And like this was like a really big deal. Like in the government, you can't get fired. This is like the one thing they told you could do, you get fired. And then I left just to move, just for geographical reasons. And it turns out that in retrospect, like 2 years, I was there 5 years. The last 2 years, like we were totally spying on U.S. people, and they totally like duped me. So anyway, I wouldn't go just for more reasons. The other reason is like I make like 2 or 3 times as much money, like not working for the government. So I won't go back to the government unless like I'm just rich, and then I have nothing else to do. But yeah, so it was fun to work there. I learned like tons of stuff. I learned like that's what got me going in this career, and I got to do tons of stuff that would be illegal if I did it now. So that was kind of fun, but I think that was like a career builder, not like where I'm planning on going back.
For the SMS exploit, the data packets or the format of that, was that something you had like public information on, or how did you have to reverse engineer that?
No, it was public. I don't remember the specs as much, but there's like that like if you were in the slides, and you can watch my talk, it has all the details. Like PDUs and UDHs, all that stuff, that's like public. Like there's like formats of that kind of stuff. And so it was just a matter of, I don't remember what the actual bug was. It was like, so the actual bug was sending in not enough data. So you would say like there was a length field, like, and you would say like 5, but you would only send like 2 bytes, and that would screw it up. That was the actual bug. But yeah, all that, like what the 3 or 4 or 5 bytes were, that was like well documented. Not by like Apple or anything, but like you could read RFCs that talked about it. Yep.
Do you have any insight into what makes a good bug bounty program? Is it just the size of the bounty, or are there other factors?
I don't know if you like one of the things I did a long time ago was like try to get bug bounty programs going. This whole like no more free bugs thing. And now I work for a company that has a bug bounty program. So we try to get people to submit bugs, and certainly the amount of money is important. Like the more money you give, the more people are interested, especially like the like best people. So if you give any amount of money, even if you don't give any money, like people will submit. So we had a bug bounty program for a long time that didn't have any money, and tons of people submitted. But as soon as you start to give money, and even lots of money, then you get like better people submitting. And so you tend to get more quality reports that way. So what can you do is more money is the easy thing to do, for sure. But the other thing you can do is figure out ways to sort of encourage them in non-monetary ways. So like give them sort of like some sort of point system, or you put their picture on the web page or something, or they can show their friends or like potential employers and stuff like that. I know ZDI has done things like fly people out to Vegas. So there's like other things you can do, but I mean, if you give them more money, it certainly works for sure for some people. Anyway, I don't have like tons of data on that, just from my personal experience. Yeah.
Just wondering if you take any security precautions, just general things that you do to keep your identity, anything safe.
Can we turn off the live stream for a second? So there's this story about the cobbler whose kids have no shoes. That's me. So I don't do any security stuff really on my own. Like my computer is there, and it was just like upstairs unattended forever. And at my house, I don't run any encryption on my Wi-Fi because to me it seems like the neighborly thing to do, right? Like my computer should not be more vulnerable because I have an open Wi-Fi. Like it should send, like when I'm on the bank, going to my bank, it should be encrypted, right? It shouldn't matter if you're on my Wi-Fi network or not. And like if my neighbor's Wi-Fi goes down, like they can use mine. That's cool. And like if mine goes down, it'd be nice if I had someone I could use. So I don't do really any encryption or any sort of security for my systems because like the stuff I'm doing is sort of like cutting edge and crazy, and like half the time doesn't work. And so like one of the things I don't want to have to worry about is like, oh, it's that firewall installed, right? It's like, no, I just want to like make things as simple as possible and make things work easy, right? And hope that everything is secure enough as it is. So yeah, my like that's why I was surprised Jono mentioned he was like, oh, I run Linux with JRSec. And I'm like, dude, I just buy my computer and I use it. You know, I use Safari and I use Apple Mail and whatever. Like it works. And so yeah, so my computers are like super. I mean, they're secure because like I'm not a total idiot. I'm not going to click on random stuff, but I don't like go out of my way to make my stuff more secure because generally when you go out of your way to make stuff more secure, it's like makes things harder to use. And I got enough problems in life and limited time. I got to make stuff work fast.
So one of the things that
that was a speedy mic. Well done. Well done.
That was like
Insta mic.
Insta mic right there. So one of the things that I watched a lot of Dave Vitale's talks, like his talk from like Echo Party 2008, Usenix 2012. And one of the things he talks about in there is about how he feels like there is really this like drop off of professionals who are really finding like these hardcore bugs, because nowadays it's like there's not like 12,000 vulnerabilities in SendMail you can find, or your modern operating systems have a whole bunch of stuff like ASLR and dep that just makes it. Just raises the barrier of entry to get into being able to find these bugs. And I was just wondering if you feel like that's the case, right? Like nobody is going to just go off on a weekend, drink a can of Red Bull, and find a heap corruption in Windows 8.1, right?
Right.
So,
no, totally. So David and I disagree a lot on like junk hacking, right? Since that's my career essentially now, and he thinks it's stupid, but I do agree with him there. So like a lot of the like really great computer security researchers now are like in their 30s or 40s, right? And you don't, like 10 years ago, the great security researchers were like 19. And the reason that that's changed, I think, is that things are so much harder now than they were then. And so it's like the things that were like super easy, like are hard now. So like when I was doing it, it started easy and it kind of slowly got harder, and I kind of slowly got better as it got harder. And so that was not like that hard for me. And so now I can do hard stuff because I got good as it went. But like if you're just getting into the field, it's really hard to be like, oh crap, like I don't even know what I'm doing, and I have to pass ASLR and dep and sandboxing, and like it's so difficult. I have to like download some like Red Hat image from 1997 to like learn how to do exploitation, and so it's hard. And I mean that's good for us as a society, but it is hard, and there's not like good ways to kind of get into it. So I totally agree with him, and I don't know how to change that, and I don't know if I want to change that, right? It might be good that like a 20-year-old can't break into my computer. Like that's like sort of a win for us, right? But yeah, no, it's totally true that things are definitely harder now. Like when I started, you could do a Stack Overflow and be done. Boop, done, right? And then it's like they added one thing, and one thing, and now it's like, when you start, you have to learn how to bypass 20 things, where when I started, you had to bypass one thing, or 0 things. And then they added one, and then I was like, well, I don't know how to do that, and then someone figured it out, and then I did. Just like the iPhone thing I talked about. So like we had this vulnerability for a long time. We didn't know how to exploit it because no one knew how. And then Alex Sonarov came up with a way to bypass, to exploit things, to arrange heap in such a way that you could exploit it. And that stuff doesn't happen anymore, right? So no one really finds ways to exploit things anymore because it's just too hard. So yeah, it's a dying field. I don't know. It's sad.
Just real quick, just a follow-up question on that. So what do you think about the state of tools nowadays? Like I remember I watched a talk from Helvar at some conference in Europe in 2012, and he was showing off like some tool that he had that was like, oh, here you can visualize the heap in real time as we're doing allocations and stuff like that. And one of the things that he lamented was that he felt that the state of tools, like the tools that people are using to be able to either find bugs or exploit them, that it just wasn't as good as he felt that it could be. And I was just wondering if you kind of agree, disagree. Do you think GDB is good enough? That's all I need. I mean,
my computer doesn't even have GDB anymore, and it makes me sad. So my computer has LLDB, which is like awful because I don't know how to use it. But yeah, no. So tools are a huge part, and like, if you have the right tools, things become easy. And we don't usually have the right tools, and like people who write tools tend to not share their tools. Like that, like Black Box Buddy tool, like I never shared that, right? Not because I'm a jerk, but just because I just never did, So, I mean, and most things have ours right. I don't know. So, like, and the other thing is, like, visualizing the heap is not really enough to keep up with, like, heap mitigations. I don't know. Like, so something I mentioned to Neil, who's from Chrysler earlier, is that we had 2 vehicles we wanted to try to, like, do security analysis of. And the first step was, like, well, we need to get, like, tools on both of them, right, to see how they work and what they're doing and what programs they use and, extract firmware and stuff like that. And so, like, on the one, we were able to actually, like, get access to it to where we could do that stuff, and so we could actually do work. And the other one, we couldn't. And it wasn't because we were stupid. It was just that they had never issued an update, and so we couldn't see how updates work. And it was like, well, with the right tooling, we could do work, and without tooling, we couldn't do work. And I mean, that's not a reason not to have tooling available. It's just like you need the right tools to do work, and half the job is having the right tools. And if you can have the right tools, things are easy, and if you don't, then things are hard. I don't know. I don't know if that answers your question. Sorry. Just rambling.
Did you ever get unbanned from the Play Store?
No. So here's a funny story about the Play Store. So I've never in my entire life updated an app to the Play Store. Never. So you would think it would be impossible to get banned from the Play Store, having never actually developed a Play Store app. Because what we would do when John O and I were trying to do research about how Google looks at apps you update is you could upload an app and not actually publish it to the Play Store. And when you uploaded it, they would actually do their analysis, and that's what we cared about, is what analysis are they doing? And so I would just upload it, see what analysis they were doing, and then write conclusions about it. I never in my life published an app to the Play Store, yet I got banned. And so I was really mad about that. I was like, this is fucking ridiculous. I've never uploaded an app, and I'm banned. This is so stupid. And so I went, and I talked to, like, their main security guy one day. I was like, come on, this is stupid. Like, I'm banned from the App Store or from the Play Store, and I've never uploaded anything. Like, please justify this to me. They're like, well, and so he said to me, he's like, well, we have this algorithm, and it figures out, like, who developers are associated with and whether those people are bad, and we try to draw conclusions on that, and we figured out that your developer account was associated with John O's developer account, and John O's developer account had been associated with installing malware. And I was like, that's, like, totally legit. I get it. I walked away. I was like, okay, fine. Like, I get it. So I've taken the ban in place, even though I've never uploaded an app. Like, it makes perfect sense to me. So the thing that's worse is my wife is actually banned as well. Because, like, once I was banned, I was like, well, fuck that. I'm making a new app or a new developer account. And you have to have a credit card. I was like, well, I'll use my wife's credit card. And I used my wife's credit card, my wife's name, and somehow they associated it with my account. And so she got banned, too. But luckily, like, that's not a huge loss for our family, so. But yeah, their algorithm works on, like, who you're, like, buddies with, and it's, like, it's legit. Like, any friend of John O should not be developing apps for the App Store. Yeah, Google knows, and, like, they have legit algos.
They had a legit reason, though. They said, if you're doing research on our infrastructure, like, okay, fine, but we're going to treat you exactly as we would treat a true adversary. So we're going to apply the same bans, the same analysis. We're not going to give you, like, flip the whitelist flag to allow you to keep doing this. We're going to subject you to our full security controls. And I was like, cool. Like,
yeah, same thing. I was like, yeah, well, okay, that makes sense.
Except
like,
for later.
Once they explained it to me, I was like, oh, yeah, like, for sure. Any friend of John O was like, I get why you would ban them.
Until later when now that, not only am I banned from the App Store, but I can't, use Google Wallet. And I want to give Google money. I'm like, I'm out of storage. Like, I have too much Gmail. I want to buy some, movies from you guys. I want to buy some devices. And I can't use Google Wallet. I'm like, I will give you money if you let me. And they're like, no. You can't, no. We can't unban you. Eventually they did. It took, 3 years. And they're finally like, okay, but just don't do anything bad. Okay.
I've heard secret rumors that I could be unbanned from Apple. And so I went through the flow. I tried to log in. They're like, sorry, there's a problem. Click here. I clicked here, clicked here. It was like, we have to call someone. I was like, that's not worth it.
The Google Flow, you go in and it says like you're suspected as fraud. Please like upload your passport and all this stuff. I went through that. I scanned everything, like I don't know, like bank account information, and they called back and they're like, "Yeah, you have like a special flag on your account." And I was like, "Oh, I'm not sure what that could be about." And they're like, "We can't. No, sorry."
That's funny. Yeah, we both have special flags. We're special people.
But when you submit it to the App Store, you submit it under your name. You would think that, like, given your iOS research, Apple might have like some sort of regex that's like, if Charlie Miller signs
That's what
up,
I said. Like
you
the
know.
fact they didn't find my app and I submitted it, like they totally failed. You know, I mean, I gave them every indication. I didn't rely. I was like, why is Charlie Miller, who's only found exploits in the past, now writing David Hasselhoff and Instastock apps? Like, this does not make sense. Like, we need to reverse engineer the shit out of this. But they never did, and instead, they just like clicked a little button and some GUI somewhere.
Any other questions? All right, thank you, Charlie, so much for coming.
Yeah, thanks. Thanks, Ann Arbor.